Okay, so for the next few days, we're gonna start working on trig part 2. So we've done some of the basic trig, that's all the stuff about triangles. What we're gonna do now is we're gonna start out by looking at some trig graphing. So we're gonna do trig graphing for the next couple of days. So we're gonna have trig graphing. Okay, so trig graphing is where we're at. So it's gonna start with I'm going to talk about the three different things. So if we think about SOHCAHTOA, so we've had SOHCAHTOA. And SOHCAHTOA is, of course, we're dealing with sine, we're dealing with cosine, and we're dealing with tangent. Now, we're talking about SOHCAHTOA, sine, cosine, and tangent. For the graphing aspect of what we're going to do, we're going to focus mostly, or almost entirely, frankly, on sine and cos. And I'll show you what tan looks like, but I'm never going to actually ask you to design or draw a tan graph, but I will show it to you. So it's easiest just to think about sine and cos. They are what are called periodic functions. So these are periodic functions. Okay, so periodic functions. And what periodic functions are things that they repeat over and over again. I've got that on there once already, so they're going to repeat over and over. Okay, so we're going to talk about the very first one. So we're going to start with the sine graph. So I'm just going to go ahead and I'm going to graph it. The graph of sine. Now, my pen isn't working as nicely here as what it normally does. I don't really know why, but nevertheless. So we're going to look at the graph of sine, and it's going to be done differently than what we've historically seen other graphs. So to begin with, we are going to draw on our axes. However, our axes are going to look somewhat different than what we're used to. I'm not going to draw the full Cartesian plane here, although this really is just part of the Cartesian plane. So if we think about a Cartesian plane as the old school we learned in, I don't know, grade 8, this is quadrant 1, quadrant, why are you not doing that? Quadrant 1, quadrant 2, quadrant 3, and this is obviously going to be quadrant 4. So what we have that we're going to deal with right now, although, as I say, this does keep going into the other quadrants. I'm only going to worry about quadrant 1 and quadrant 4 right now. So I don't know how well this is going to work because my pen isn't going to be all that smooth, but the graph of sine, so what I'm going to do here is this is going to be the graph of y equals the sine of x. Wow, it's really not cooperating very well right now. So y equals the sine of x. So I'm going to just draw this in as smoothly as I can. Okay, and so this is what it looks like. And so these humps should be about the same height. But what we have here is this has a maximum y value of 1 and a maximum negative y value of negative 1. And from this point right here to this point right here, it's actually going to be measured in degrees. And this is 360 degrees. Okay. Now, I said it's a periodic function because it repeats over and over again. So even though I've stopped it here, the reality is this just keeps on going. Okay. And it should be, and again, I've not done a fantastic job of making it symmetrical, but if this is 360 degrees, to finish another complete, and this is called a cycle, so you can finish another complete cycle would be another 360 degrees, right? So from here to here, this distance would be another 360 degrees, okay? So what that means is that If this is 360 and we go another 360, this would be 720 degrees. And if we wanted to, we could go out and we could do another full cycle. It would go like that, and it would be yet another 360 degrees. Okay, so 360 degrees. This is really being more difficult than it should right now. So that would then, so if we add another 360 onto that, that would take us to 1,080 degrees. Okay, and so this keeps on going, and it keeps going this direction as well. I'm just not going to worry about showing that right yet, but if it completed another cycle out there, when it was done, it would be at negative 360 degrees. And so this has a lovely amount of symmetry, that one full cycle is 360 degrees. That means right at this spot right here, it's halfway. So that's going to be 180 degrees. Okay, so we've got 180 degrees there. So a couple of things I want to define here is one cycle. Wow, this is really being cantankerous. One cycle is how far on the x-axis we travel. Wow, this has never been this bad before. We travel before the exact, wow, pattern, pattern repeats itself. Okay, so how far do we have to go before the pattern repeats itself? So it doesn't mean it has to get back to the same position. Okay, it means how far do we go before it does the exact same behavior again. So if we look at the sine graph, if we it doesn't really start at zero. I'm going to say we start at zero just to kind of get us thinking a little bit more readily. But it is how far do we have to go before it repeats the same pattern. So it starts at zero, it goes up, 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 so it comes back down, and it hits zero again. Okay, it's come back to the same position, but it doesn't mean that the pattern is repeating, because now it's going downwards, whereas here it was going upwards. So one cycle is how far it goes before it repeats the pattern again. So downwards and then back upwards, and it gets to zero. And then what we have here is obviously, this chunk, right? So this chunk here matches what this chunk back here does. Okay, so how far does it need to go before it exactly repeats what's going on? So in this case, the cycle is 360 degrees. So for y equals the sine of x, the period length is exactly 360 degrees, because that's how far it goes before it repeats itself. Okay, so cycle, the definition of a cycle right here, right? So one cycle is how far on the x-axis we travel before the exact pattern repeats itself. So in this case, it is 360 degrees before it repeats itself. So that's one thing that we need to know, is we need to know cycle. The other name for this, the proper name that we're going to use most of the time, is this is called the period length. Okay, so period length. So there we go. The period length is how far. It's one cycle. The period length is how far it goes before it repeats itself. So that's really important. So that's one term that we keep track of for sinusoidal functions. The next thing that we're going to talk about is we're going to talk about amplitude. Okay, so if anybody here is a snowboarder or a skater, amplitude is how high, how far from the center line a function can get. So amplitude is a description of how big the distance from the center line the function can get. So the center line here is at 0, right? Doesn't always have to be 0, and we're going to definitely deal with cases where it's not 0, but amplitude is how far from the center line we can get. And in this case, we can go from 0, right, all the way up to 1. So amplitude is how far from the center line the function can get. Okay, so just how far from the center line can the function get? In this case, you can see that it gets 1 away. So amplitude is how far from the center line the function can get. So 2 terms so far. We've got cycle, also known as period length. Okay, amplitude, how far from the center line can we get? And then really, those are the 2 main descriptors we're going to have. When we go to graph things, so this center line concept is important, right? So the center line is a description of what this thing cycles around, okay? So the center line is another thing that we're going to keep track of. So center line, wow, I'm going to have to take a moment off here in a bit and see if we can figure out what the heck's going on with my pen. So the center line is something that we're going to track. So there are a few things. So we're going to check the period length, we're going to check amplitude, we're going to check center line, and then the last thing that we're going to talk about is it's a fancy term, it's called phase shift. Phase shift, okay? And that's the last thing that we're going to track when we're talking about graphs. So for sine, it has a period length of 360 degrees. That's the default period length for sine. It's got a default amplitude of 1. That's how far away from the center line it can get. It's got a default center line of 0. It's centered about the x-axis, and it has no phase shift. So phase shift, really what phase shift talks about is how far left or right from the standard position the function is moved. Okay, so that is the basics. I'm gonna pause the video here and see if I can figure out what's going on with my pen, and I'm gonna come on back.